Hello everyone, let us see the next example of Fourier series. Find Fourier series for the function fx is equal to x square in the interval 0 to 2 pi. Additional one more bite is there, one more question is there, that is we have to prove that pi square by 12 is equal to 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square and plus dot dot, and this is an infinite series. Okay, first we have to find out Fourier series, and after finding out the answer for Fourier series we have to put the value of x, particular value of x. We have to guess the value, what value of x we will get this series. That's it. Okay, let us start with the Fourier series first. Fourier series by is given by, in this interval, fx is equal to a0 by 2. Formula is same. Call that equation number 1. Now we have to calculate a0. a0 is 1 upon pi integration 0 to 2 pi of x dx. Well, the value of fx is x square dx. Now x square, rest of the terms as it is, x square integration is x cube by 3, limit 0 to 2 pi. Take this 3 outside, 1 upon 3 pi. Put the value of upper limit 2 pi cube minus lower limit 0. Now we know 2 pi cube is 8 pi cube. 2 cube is 8, pi cube is pi cube, divided by 3 pi. 1 pi gets cancelled, answer is 8 pi square by 3, the value of a0. Okay, now let us start with an. An is equal to 1 upon pi integration 0 to 2 pi fx cos n x dx. This is the basic formula. Put the value of fx is x square into cos n x. And x, again u into v rule here, same. U is arithmetic, v is trigonometry. Again, rest of the terms as it is, start with the u into v rule. U into integration of cos s sin n x upon n minus x square derivative here, 2x. This integration here, sin n x integration minus cos n x upon n, already n is there, that's why it becomes n square. Now next term minus becomes plus, 2x derivative is 2, and this integration here, for in that minus and 1 upon n square is a constant. Cos n x integration is minus plus sin n x upon n, already n square is there, that's why it becomes n cube. And next term will be minus 2 derivative is 0, that's why the series stops here, limit 0 to 2 pi. Okay, now remove this bracket first, or you can neglect this sign term, because sin 0 is 0 and sign for upper limit 2 and pi is again 0. For both the limit, sign terms vanishes, therefore you have to just concentrate on this term. Okay, minus becomes plus 2x cos n x upon n square, this as it is 0 to 2 pi. Put the value of upper limit in x, 2 into this 2 pi, cos 2 n pi is 1 divided by n square as it is, minus lower limit 0, 0 into anything is 0. Okay, therefore pi gets cancelled, answer is 4 upon n square. Now similar way, start with bn. What is the difference between an and bn? Just replace cos by sin here, just integration, middle integration is different. Okay, these are the steps. U into v rule, same rule we have to follow. The answer for this bn is this. Okay, now what we have to do? Put this value of a0, an and bn in the original Fourier series 1. Therefore equation number 1, this equation number we will call it as 1. Put this value of this here, it becomes Fourier series 1 implies fx is equal to a0 by 2. a0 is this one, a0 is 8 pi square by 3 divided by 2 means 2 4s are 8, 4 pi square by 3 plus summation an is 1 4 by n square cos n x plus summation bn is minus 4 pi by n sin n x. This is the final answer. Just to replace fx by our function fx is x square, this is as it is. Take 4 common only, constant outside of the summation is over n, therefore apart from n everything is constant, take out, so we can take outside. minus 4 pi is a constant, take outside from this second summation, sin nx upon n. Okay, this is the Fourier series formula we have calculated that first question. Now what is the additional question here? Hence prove that pi square by 12 is equal to 1 upon 1 square minus 1 by 2 square plus 1 by 3 square and so on. For that we have to expand these summations. Now x square this as it is plus 4 as it is. What is this summation? We are going to put the values of n 1 plus and go on adding those terms. Then 2, then 3, these are the integers, positive integers. Put n value 1 here, we get cos x upon 1 square. N square is 1 square. Plus put the value of n is equal to 2, we get cos 2x upon 2 square. Plus cos 3x upon 3 square plus and dot dot, these are the infinite series. Minus 4 pi as it is. Now put the value of n is equal to 1, sin x upon n 1 plus sin 2x upon 2 plus sin 3x upon 3 plus and dot dot so on. Okay, now if you observe this series, we want this one 1 upon 1 square 2 square 3 square 1 square 2 square 3 square, these are the in the denominator, they are available in this bracket only. That's why we have to put the value of x on the both side, such value of x on the both side, so that this series becomes 0 and this series becomes alternating plus minus sign. For that, if we put 0 here, it sin x becomes 0, but you will get all the positive terms here. You will not get this alternating plus minus. That's why we are going to put the x is equal to pi in the series. Let us see how it works. Put the value of x is equal to pi in the both side of above series. We get pi square is equal to 4 pi square by 3 as it is plus 4 as it is. We know cos pi is minus 1, cos of 2 pi is plus 1, cos of 3 pi is minus 1. You can calculate on this calculator. Okay, whole divided by 1 square 2 square 3 square as it is plus and so on. Minus 2 4 pi, and we know sin 0 sin pi, sin 2 pi, sin 3 pi. By putting x is equal to pi, everyone becomes 0, everything becomes 0. Second term. Okay, now we have to simplify. Take this term on that side, pi square minus 4 pi square by 3 is equal to 4 into bracket this as it is. Now pi square cross multiply, we get minus pi square by 3 is equal to this term as it is. Take this 4 to the denominator and multiply throughout by minus, we get pi square by this 12 is equal to multiplying by minus, and we get this term plus 1 upon 1 square, this term minus 1 upon 2 square, this term plus 1 upon 3 square minus and so on. This is what we have to prove. Okay, now let us see next. Find Fourier series for fx is equal to x sin x in the interval 0 to 2 pi, and hence prove that summation over n is equal to 2 to infinity. This is 2. Okay, now 2 to infinity 1 upon n square minus 1 is equal to 3 by 4. Okay, these are the two questions. This is sub question. By finding out this answer, we have to put particular value of x in the series so that we will get this answer. Okay, let us start with the Fourier series for this function. Fourier series is given by, this is the formula we know, call that equation number 1. Now start with a naught. A naught is 1 upon pi 0 to 2 pi fx dx. What is fx? X sin x into dx. Again rule u into v rule we are going to apply. 1 upon pi as it is, u into integration of sin x minus cos x minus x derivative here 1, cos x derivative minus as it is, cos x derivative integration is sin x. Okay, next will be 0 because one derivative becomes 0. You have to follow this procedure until this term should be constant, so that next term will be 0. Okay, from the limit 0 to 2 pi. Now put the value of upper limit and lower limit. We know cos sin 2 pi and sin 0 is 0. No need to write this term. Now here put the value of x is equal to 2 pi, and we know cos of 2 pi is plus 1, it becomes minus 2 pi. And for lower limit 0, everywhere it becomes 0 into anything is 0, sin 0 is 0. That's why the process completed here. Now minus Pi gets cancelled. Answer is for a naught is -2. Okay, now let us start with an. An is equal to 1 upon pi integration 0 to 2 pi fx cos n x dx. Now put the value of fx is x sin x into cos n x dx. Now here this is a multiplication of three trigonometry or three functions. Therefore we have to use the formula, basic formula sin cos. Which one? This one. 2 sin a cos b. Okay, sin a cos b. Sin a cos b. Here 2 is not there, that's why we have to take this 2 and that side, that is half 1 by 2. Sin a cos b, what is a? X. What is b? N x. What is sin a cos b? Sin a plus b plus sin a minus b. Therefore it becomes sin a plus b x plus nx plus sin a minus b x minus nx. Okay, this is a basic formula. Now take this 2 outside because it is constant. 1 upon 2 pi integration as it is x into sine. Put this take this x common outside the integration. 1 plus n into x plus this x, take this x inside to the bracket, x into sine 1 minus n into this, take this x outside, into dx. Okay, now again these are the two integrations separate. We have to use u into v rule. Again make the curly bracket bigger, and now first bracket for this first integration, u into integration of sine x into integration of sine is minus cos 1 plus n is a constant, x upon derivative of this angle should be divided, that is 1 plus n, bracket complete. Now minus x derivative is 1, minus as it is this term's integration here. In that minus n 1 upon 1 plus n is constant. Cos integration is sine 1 plus n upon x, 1 plus n into x, divided by angle derivative 1 plus n should be divided. Already 1 plus n is there, that's why it becomes 1 plus n bracket square. Next term will be 0 because it becomes derivative of 1 is 0. That's why first integration complete here. Okay, 0 to 2 pi, or you can cumulatively write down this 0 to 2 pi here also, no problem, because limits are same. Plus now this integration, what is the difference? Only angle 1 plus n. Instead of 1 plus n, it is a 1 minus n. That's why write down all this as it is. Instead of 1 plus n, here 1 minus n you have to replace. Okay, only angle is different. That's why derivative is same, integration is same. Now 0 to 2 pi, curly bracket complete of whole the term, because this 1 upon 2 pi is multiplied to all the terms, all two terms. Now we have to put the limits. Before that, just replace this, remove this constant. This minus x cos this upon 1 plus n, minus minus becomes plus sine 1 plus n upon 1 plus n square. This is again minus x into cos 1 minus n x upon 1 minus n, and minus minus plus x into this x into it is minus minus only plus sine 1 minus n into x upon 1 minus n bracket square as it is. Limit 0 to 2 pi. Now again we know, put this, put this upper limit here, we get into x, we get minus it 2 pi. Here also 2 pi, take this inside to the angle 2 pi plus 2n pi. Here again denominator as it is, sine 2 pi plus 2n pi divided by as it is minus 2 pi into cos of 2 pi minus 2n pi divided by 1 minus n, and plus sine 2 pi minus 2n pi divided by 1 minus n square. This is called upper limit, total complete. For lower limit, we have to put 0 in x. It becomes 0 into anything is 0, sine 0 is 0, 0 into anything is 0, again sine 0 is 0. For lower limit, total terms become 0. Okay, now we have to solve. We know cos of 2 pi plus theta is cos theta, sine of again 2 pi plus theta is sine theta. Again 2 pi, sine 2 pi minus theta is again sine theta. Therefore, it becomes cos of 2 pi n and this cos of 2 pi n only the terms remaining here. It becomes cos of 2 pi plus theta is cos of 2 pi n, it becomes 1 minus 2 pi upon 1 plus n, and here these terms gets cancelled, sine terms gets cancelled for these angles, and 2 pi into cos of 2 pi minus theta is again cos of theta, that is 2 pi n, becomes 1 minus 2 pi upon 1 minus n. Okay, now we have to simplify this first. Minus 2 pi take outside, or 2 pi outside, and cancel with this 2 pi. It becomes minus 1 upon 1 plus n, minus 1 upon 1 minus n. Now cross multiply, we get 1 minus 1 plus n, and this minus 1 minus n divided by multiplication of these two. And this n gets cancelled, minus 1 minus 1 minus 2. A plus b into a minus b is a square minus b square, that is 1 square minus n square. And again take this minus to the denominator and reverse this term, we get 2 upon n square minus 1. Okay, now in our formula n start from 1 to infinity. Okay, if we put n is equal to 1 here, it becomes 1 minus 1 0, and any number upon 0 becomes infinity. Infinity is not acceptable answer in any example, that's why here we have to put one condition. It is so the answer for n is equal to this if n not equal to 1. For n is equal to 1, we have to find out those values. Okay, in any example where denominator is like this, where if you put n is equal to 1, it becomes infinity, then we have to make sure that it should not be equal to 1. And in next step, we have to find out those values for n is equal to 1. Okay, now our next step will be first find out bn here. 1 upon pi, this is the formula. What is the real difference of an and bn? Just replace cos by sine. Here also x sin x into this sin x. This is a homework for you. Similarly, already we have calculated an. Similarly, we have to calculate bn like this only. Here hint is given, sin a sin b, you have to use this formula. 2 sin a sin b is cos a minus b minus cos a plus b. And answer for bn is 0 here. Okay, this is the homework for you. Now once we calculate a naught, an and bn, we have to calculate for n is equal to 1 value in this particular example, that is a1 and b1. Suffixes are for an and bn, not a naught. That's why by putting n is equal to 1, we get a1 and b1. We have to calculate a1 and b1. First let us see a1. Put the value of n is equal to 1 in an formula. We get a1 is equal to 1 upon pi integration 0 to 2 pi fx cos 1x, that is cos x dx. How we get it? By using formula for an. What is the formula for an? This one. By putting n is equal to 1, we get cos x here only. By rest of the terms as it is. Okay. Okay. Now put the value of fx, that is x sin x, into cos x as it is. Now we know 2 sin x cos x is sin 2 theta. Therefore, adjust 2 here, divided by 2. Then take this 2 outside, 1 upon 2 pi x as it is. 2 sin theta cos theta is sin 2 theta dx. Okay. Again, now this is u into v rule we have to apply of integration. The rest of the terms as it is. U into integration of sine is minus cos 2x divided by 2. Derivative of 2x is 2. Next term minus x derivative is 1. This integration here, minus as it is, 2 as it is, cos integration is sin 2x upon 2. Already 2 is there, that's why it becomes 4. 2 into 2. Next term will be plus 1 derivative is 0. That's why process stops here. Limits from 0 to 2 pi. Now we know cos of sine of 4 pi. If you put x is equal to 2 pi here, it becomes sine 4 pi is 0. And lower limit is also sine 0 is 0. The only remaining term is cos. Put the upper limit 2 pi here, we get 2 pi into minus cos of 4 pi is 1. You can calculate on calculator. Cos of 4 into pi means 180 degree. you will get the answer 1 divided by the 2 as it is. And sine 0 and sine these are 0 only. Lower limit is also 0 into anything is 0. Sine 0 is 0. Okay, now this 2 pi gets cancelled. Answer is 1 half minus 1 half for A1. Now we have to calculate B1 also, because in the second series summation, second summation, Bn is there. Therefore Bn is, put the value of n is equal to 1, we get B1 is equal to 1 upon pi integration 0 to 2 pi fx sine x only dx. Okay, how we get it? By putting here Bn here. In this Bn you put n is equal to 1, we get here is n only, we get this formula. Now similarly in above fashion you will solve this. Okay, this is the steps, these are the formulas. Now this is B1, these are the formulas, these are the steps. Answer for Bn is pi. Okay, this is again multiply x inside, we get x minus, here also u into v rule applied. Okay, x integration is x square by 2 minus as it is, and for u into v rule put the bracket, double curly square curve bracket, simple bracket. This is u into v rule. Okay, and simplifying this by putting the upper and lower limit, we get this answer pi. Okay, therefore the Fourier series from equation number 1 this is example. The Fourier series fx becomes a naught by 2, a naught is this one minus 2 by 2, this is a naught is value minus 2 by 2 plus summation over n, 1 is over n is equal to 1 to infinity a n cos nx plus b n sin nx. Okay, now we have already calculated n is equal to 1. Take that term only outside of this summation, put n is equal to 1, we get a1 cos 1x. This is minus 1, this is fx value, and again one term we have to take outside by putting n is equal to 1, b1 sin 1x. These are two different terms because a1 and b1 were calculated separately. Plus now this summation start from 2 here. Okay, 2 to infinity, same terms. Now put all those values here, we get this is minus 1, a1 value we have minus half cos x plus bn value is pi sin x plus summation an is 2 upon n square minus 1 cos nx plus summation bn is 0, that's why no need to write 0 here. This is the answer. Therefore x sin x is equal to minus half. This is the answer for this. Take two constant outside of the summation only. Okay, now this is the main part. First question of this main question. Okay, now first complete question completed for this Fourier series. Now we have to prove that this summation is equal to 3 by 4. We get this answer. Okay, now we have to prove this. This 1 upon n square minus 1 summation over 2 is here. That means we have to put such value of x here on the both sides so that this becomes 1. That's why I put x is equal to 0 in both the side. What we get? 0 into anything is 0, minus 1 minus cos 0 is half, cos 0 is 1 minus half, plus this is sin 0 is 0, no need to write to 0, plus 2 as it is, summation over n, cos 0 is 1 upon n square minus 1. Okay, now simplify. Minus 1 minus half become minus 3 by 2 plus this 2 into as it is. Now take this term as it is and rest of the terms on that side. It becomes plus 3 by 2 and 2 comes to denominator, it becomes 3 by 4. This is what we have to prove.